just until Artemia, no dry feed, still really late. This is a day 40 fish using the new protocol. And so it was easily 3 times the size. And it was very obvious in the tanks that the fish were different, they were behaving different. They actually looked and acted more like real fish. And that's what led to the successful settlement of the yellow tang. So basically, right around day 55 was the first one that turned kind of yellow-ish, somewhere between this and this. And then shortly after that, more and more dropped down, became yellow. It takes about a week from then to the time they start kind of getting a hint of yellow till they turn solid. It's about a week. So that was really kind of where we were. And what we had found was, that was really exciting. We got the juvenile yellow tang. It was obviously a landmark thing, and we're really excited about it. But what we were so frustrated by was that we're still losing most of the fish early on. Still losing most of the fish in that first week. And that's why I brought in several graduate students, and you're going to see one of them talk today. But really, we had kind of 3 fundamental hypotheses of why the fish were dying. And I had these 3 students looking at these hypotheses. And one of them is that there's pathogenic bacteria associated with our live feeds. It's pretty widely known with a lot of other commercial forms of aquaculture that these live feeds are dirty, that you're bringing in all kinds of pathogenic bacteria, potentially pathogenic bacteria. And so there's a long list of bacteria present in hatcheries and shellfish hatcheries and what literature they come from. And the ones that are circled are the ones that we found at MBI. So we've actually done some work and identified bacteria there, and we know we have these pathogenic bacteria there. So it's a reasonable thing to think that maybe we're bringing these things in with our feeds. And fairly early on, we did some work with antibiotics, which is not a good long-term solution to bacterial problems. But we wanted to see if the use of antibiotics corrected some of the mortality issues we were having. And I won't go into all the details, but we basically did a trial where we had water and feeds and various combinations of things treated and untreated with antibiotics. And when we treated the algae, interestingly enough, when we treated the algae with antibiotics, we ended up with much better survival in the larval fish. And so that kind of indicated to us that we kind of knew that bacteria was an issue, so we could trace down how to avoid it. And the traditional ways of identifying bacteria, you plate things, you do colony morphology and cell morphology, and you kind of look at reactions, and you can identify bacteria that way. But it just so happens that OI recently built a really nice fancy new molecular lab, and we have access and ability to do DNA extraction and isolation and sequencing. So my one grad student, her thesis project looked at the bacteria communities associated with copepods, and by taking the copepods, extracting the bacteria DNA, sequencing that DNA, and doing some sequencing analysis, we were able to characterize the bacteria communities, or start to characterize bacteria communities